So special systems. So we're going to start off with a review. Remember, linear systems have how many possible types of solutions? 3, right? 3 possible types of solutions. The first one is a single point of intersection. Can somebody read that graph and tell me what you think the value of the point of intersection is? It might be easier to read on your paper than on the screen. Maybe it's easier to read on the screen than your paper. Kaylin? Negative 1, 1/2. Okay, negative 1, 1.5. All right, or negative 1, 3/2. That is the solution, right? The point of intersection right there. And if we were to give a word type solution, we would say consistent and independent. Consistent, independent. Don't forget, consistent means there is a solution. Independent means there's just one solution. So there is a solution, there's only one. All right, the second scenario, our solution is now what? Infinite points along the line. Infinite points along the line. So again, whether you can read it off the board or whether you can read it off your paper, probably off your notes is easier. Take a look at your notes. Give me now the written solution, not the word solution. What is the written solution? How do you say the infinite points along the line? How do you say the infinite points along the line? Ethan? Those are the words. I don't want it said, not the words. You got to tell me the infinite points along the line. Nick?
Y equals x plus 1.
Y equals, Nick says, x plus 1. Does anybody agree? Here's what Nick said. Nick said the y-intercept is 1, and Nick said the slope is 1, right? Y equals x plus 1. Is the y-intercept 1? Don't tell me you don't even remember what a y-intercept is. Whoa. Okay, you don't remember that. You just pack it in and ask to go to easy math. Okay? I mean, I can teach you this stuff. We've learned it. We've done it enough. It's your responsibility to remember it. So the y-intercept is 1. Is the slope 1? What do you think the slope is? 1 over 2. The slope is 1/2. Slope is 1/2. You're going to guess? Well, it's right in front of you. Why are you guessing? What's the slope? How many say it's 1/2? Who has something else? Who has something else? John? 2 over 1. How many think it's 2 over 1? Okay. Who has something else? Andrew? Who has negative 2 over 1? Or who has something else? Who has something else? Adriana? Who has negative 1/2? I don't know why that's not everybody. What's the top of the slope? Horizontal or vertical? What's the top of the slope? I got to tell you, if you even hesitate half a second, I don't know where you've been all last chapter. I don't know where you've been. Is the top of the fraction of the slope the horizontal or the vertical? Which is it? If you're hesitating, you got to study. You have got to study. You've got to study. You're not studying. Because I can teach that. I can teach this to a kindergartner. To say the top is horizontal or the top is vertical. No one's brain here is incapable of that fact. Top is vertical versus top is horizontal. Everyone's brain is capable, no matter how intelligent you are or lack thereof. The only issue is, have you memorized it? And you got to memorize it. You can't be getting that wrong. The top is the vertical change, the up and down. So what's the bottom then? The horizontal change. If you go up to the next point, that's positive. If you go down to the next point, that's negative. On the bottom, if you go right to the next point, it's positive. If you go left, it's negative. I'm at the y-intercept. If I go down 1, is that positive or negative? Negative. And if I go right 2, my slope is negative 1/2 x, or my slope is negative 1/2, therefore I get y equals negative 1/2 x plus 1. We spent the whole chapter on that. Not only did we spend time on what the slope is, we spent time on how to write the equation of the line. And we had 4 different scenarios. And all of them involved writing the slope and the y-intercept, and one of them in particular was writing it off a graph. We've done this. This is a review. And none of you had any problem with it the lesson I taught it in class. You didn't have any problem comprehending it. You have problem remembering it. That's on you. You got to study. You think you're going to remember all this stuff, you're crazy. And you better be careful about your short-term memory. Because your short-term may be good, but boy, oh boy, you're proving your long-term ain't so great. Okay, so that's the second situation. In words, this is going to be consistent and dependent. It has a solution, so it's consistent. But there are an infinite number of solutions, all the points along the line, therefore it's dependent. All right, and the last thing is what solution? No solution. And how do we say that? Null set. Whenever it's the null set, the lines must be parallel. Parallel lines have no intersection. So it's a null set because we have parallel lines. And therefore, in words, the solution is inconsistent, meaning there is no solution. Okay, so let's review. We started off the whole chapter with this. So why am I bringing it up now? Okay, so think about where we've been. We've learned 3 methods of solving a system, linear system. We learned by, first off, graphing. Second by substitution, and third by elimination. Now, in graphing, can we tell if it's consistent and independent? Yeah, there's a point of intersection. Can we tell if it's consistent and dependent? Yeah, we graph the same line. Can we tell if it's inconsistent? Yeah, we graph parallel lines. No problem, right? What about in the other 2 mathematical methods? Isn't it still possible to have the same line or have parallel lines? How are we going to know mathematically? How are we going to know? Because we're not graphing them, right? The substitution method, do we graph it? No. Elimination method, do we graph it? No. So we have to figure out what happens in these scenarios so we're aware of them. Okay? So that's what today's lesson is. What causes it? What's the situation when it's consistent and dependent or when it's inconsistent? Okay, so B, when solving by substitution or elimination, if the variable, parentheses S, variables disappear, if the variable disappears or the variables disappear, you'll say, what do you mean disappear? I'm telling you they're gone. For example, substitution. Okay. You solve one equation for one of the variables, and you sub it into the other equation, and you go to solve the equation, and the variable adds out, it's gone. Or you're in elimination. You decide, let's say, to get rid of the x's. So you do what you do to get rid of the x's, and when you add up the whole thing, the y's are gone too. They're both gone. How can I continue? I have no variables. Well, that's the condition that's either going to be consistent and dependent or inconsistent. That's why the variable or variables disappeared. Because this one's either inconsistent or consistent and dependent. It's either the same line or parallel lines. Now, how do we know which one of the two? So again, if your variable or variables disappear, they're gone. Whoosh. Bye-bye. You have nothing left to solve. You just got numbers left. You can't solve for the variable, it's gone. You know, hey, it's either the same line, consistent and dependent, or it's parallel lines, and it's inconsistent. How do you know which is which now? You know it's those two. Now you got to figure out which of those two. It's really quite easy. If what's left is true, if what's left is true, yeah, for example, your variables disappear and what's left is like 7 equals 7. Is that true? That's true. Your variables disappear and what's left is like 0 equals 0. Is that true? That's true. You only have numbers left. Your variables are gone. If what's left is true, which one do you think it would be? Consistent and dependent or inconsistent? Well, if you're smart, you can see there are 2 blanks there. So hopefully you say consistent and dependent. So what just happened? These were the same line, like number 2 above. Which, by the way, if they ask you for the solution to a consistent and dependent, what do you have to give? The equation of the line, right? Just like we did on number 2 above. Okay? So what if your variables disappear and what's left is false? Maybe you get something like this. 3 equals 8. Last time I checked, 3 didn't equal 8. Maybe you get something like 0 equals -4. Last time I checked, 0 doesn't equal -4. The numbers that are left are false. Therefore, it's got to be inconsistent. It's got to be inconsistent. Therefore, these must have been parallel lines. Had to be. And this is like number 3 above. Had to be parallel lines like number 3 above. Okay? All right, see if we can then put it into practice. So just a couple examples. Because we already know how to solve, right? We already know how to do elimination. We already know how to do substitution. Okay. If you look at number 1, it could be solved either way. Let's go with elimination. All right, just for the fun of it. Let's go with elimination. And let's say I chose to eliminate the x's. What would I do to which equation to get rid of the x's? Now I want everybody thinking because I'm going to call on you. What would I do to get rid of the x's? Antonio, what would you do? All right, hold on. Were you thinking already? Okay, what would you do?
Add -4x to the other side.
Okay. That wouldn't be solving by elimination. You're thinking of substitution. But I'm trying to get rid of the x's. Both x's I want to go away. So what would I do? Byron, what would you do? Will that get the top and bottom x's to be equal and opposite? You're close, Byron. When I do a 2 on top, what's the x going to be on top?
8.
And what's the x on the bottom? No, the bottom one's 8. The top is now 8 and the bottom's 8. Does 8x plus 8x equal 0? -2. Okay. We got to multiply the top by -2. Remember now you got to distribute. So we're going to have a new blue. -2 times 4x, -8x. Oh, good, they're equal and opposite. Be careful here. You mistake-prone people. -2 times a -1y is a positive 2y. And don't forget the right-hand side. -2 times 9 is -18. We now have our old black and our new blue, and we are now ready to add them, right? Old black and new blue. 8x minus 8x is? Negative 2y plus positive 2y is? And I end up with 0 equals 7 positives and 18 negatives is? I end up with 0 equals negative 11. My variables both disappeared. Whoosh. What's left is true or false? It's just false. Last time I checked, 0 didn't equal negative 11. Therefore, what's the solution? What's the solution? Okay, it is inconsistent is the words. The solution is the null set. So conclusion is the lines must have been parallel. Parallel. By the way, parallel lines have the same what? Slope. That better be in your brain too. Same slope. Okay. You guys don't need to do this. Just watch this. I'm going to go ahead and do this one by substitution. Okay. So if I were going to go substitution, this is what I would do. I would add a positive y to both sides. Then I would add a negative 9 to both sides. Now I've isolated the y. All right. Again, just watch because I'm going to go fast. Now where the y is, I'm going to sub that in. Negative 9 plus 4x. So I still have the 8x minus, and I'm going to distribute. Negative 2 times a negative 9 is a positive 18. Negative 2 times a positive 4x is a negative 8x equals 7. Look what happens when I add up my x's. Whoosh. 8x minus 8x is 0. What am I left with? 18 equals 7. Is that true? False. And what would I say? Inconsistent, the null set, right? No matter which method you went, in the left, both variables disappear. In this one, again, you're only down to 1 and it disappears. In that situation, read what's left and determine the solution. All right, so try number 2, and we'll stop there. I'm going to pause the video. All right, being almost everybody did elimination, I assume you decided to get rid of the x's. You could have decided to get rid of the y's, but you would multiply the top by a negative 3. Our new blue would be a negative 3x. Negative 3 times a negative 3y is a positive 9y. And a negative 3 times a positive 2 is a negative 6. You would now add up your black and your new blue. Positive 3x and negative 3x, 0. Negative 9y and positive 9y is 0. 6 minus 6, 0. 0 equals 0. Now I'll tell you this. In the elimination method, whenever it's consistent and dependent, the left is always 0 because both variables have to add out. And when the right is 0, then that is, of course, true. And this is going to be consistent and dependent. Is that all you wrote? Did anybody write anything else? Did anybody actually give the solution besides describing the solution? Because all we've done right now is describe the solution. I want the solution. Anybody have the solution on their paper? Nobody has anything more than the words consistent and dependent? Is that all we did for number 2? Is give the words? What's the solution to number 2? Somebody give me the solution. Andrew? Say again? Nope. Not every point is the solution to this. Only certain points. There are an infinite number of them, but it's not every point in the graph. Raquel? No, that's not. That doesn't describe the solution. Again, I'll show you. Over here, the solution is this point, and this point, and this point, and this one, and this one, and this one, and this one, and that one, and that one, and this one, and this one, this one, this one, this one, this one, that one, that one, this one, this one, this point, this point, this point, that one, that one, that one, that one, that one, forever that way. This one, 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 that, this, that, this, that. Kind of curve in there. All right. So, Andrew?
Y equals,
What is it?
Y equals x plus 0.
No, that would not be the equation of the line, although you tried to give me an equation of the line. Wow, it's way, way, way easier than that. Like, way. Adam?
Y equals 0.
It's got to be the equation of a line. You want me to graph y equals, I'll graph for you y equals 0. Here is y equals 0, a horizontal line at going through y value of 0. That's y equals 0. Let me ask you this question. If you graph this, what would you get? What would you get? What would the graph be of just the thing in the purple box? What would you get? You would get a... What kind of shape would you get if you graph x minus 3y equals 2? You would get a... What would happen if you graphed 3x minus 9y equals 6? What shape would you get? What would happen if you graphed negative 3x plus 9y equals negative 6? What shape would you get? My answer that I have to write is a... Nobody can give me the equation of the line? Okay. So, don't draw this, just think. All right, so let me think. I don't even care what this thing is. I just care whether it goes up or down. Okay, so roughly the blue line is about like that. And the black line is like that. And the new blue, which I'll do in purple, is like that. Right? Can you give me an equation of the line? How about x minus 3y equals 2? Is that the equation of the answer of the line? Is that the equation of the line? If you graphed x minus 3y equals 2, won't you get the line? That's the equation of the line. X equals, or I'm sorry, x minus 3y equals 2. Or you could have said 3x minus 9y equals 6. Or if you really wanted to, you could have said negative 3x plus 9y equals negative 6. They're all the equation of the line. And the line is the answer. The equation of the line is the answer. And all three of them are the equation of the line. If you were graphing this, you would get one line right on top of the other. The line. What would you have graphed? This. And some of you are looking cross-eyed at me. What in the world? What are you talking about? Because here's your problem. You don't fully understand that this is slope-intercept form of a linear equation or a line, and this is standard form of a line. They're just two different forms. Look, if I said to you 2/3 or I said 4/6, aren't they two different forms of the same thing? 2/3 and 4/6? They're two different forms. This is graphing form, and this is standard form. But if I'm asking for the equation of the line and I don't say, give it to me in graphing form or give it to me in standard form, you can give it to me in either form. Why did I give this answer in standard form? Because it was already in standard form. Why would I waste some time putting it in slope-intercept form? Why did we give this answer in slope-intercept form? Because we were reading it off the graph. And how do you read off a graph? You read the y-intercept and you read the slope. So we use y-intercept form for that. Because this one, we were reading it off a graph, and that's when you use y equals mx plus b. And this one, they already gave it to us in standard form. So why would I take any more time to figure out what y equals when it's the exact same thing in a different form? I wouldn't. I simply would write the equation of the line. All right, so that's the answer. X minus 3y equals 2. or 3x minus 9y equals 6, or if really you wanted to, negative 3x plus 9y equals negative 6. All right, you better take some time tonight and try to understand what's going on as you do your homework.